Alright, ladies and gentlemen, Algebra 2 kids, this is the key for the practice 5.1 to 5.3. The axis of symmetry is found by using the opposite of b over 2a. That's also how we find the h value for the vertex. And then we take that h value and we plug it in for x, and when we do that and follow the order of operations, we can find the y value that goes with it. That's k. Now, some of you I noticed in class are not following the order of operations here. You need to square the value first, then multiply by -1 to get this value. Some of you were multiplying the negative inside and then squaring it, which would make it +1, and that is a problem. Okay, I'm going to go through here and just kind of show you some of the answers. So question 2, I did the exact same thing. I threw in the axis of symmetry right there, and then we found that we used that to find the y value that went with it. Now you're going to see on question 3 I did a lot of extra stuff because I wasn't paying attention to the actual answer. For those of you wondering what you really needed to do, find the y-intercept, all I needed to do was plug in 0 for x, and when I do that I get 7. So that should have been a lot easier than I made it because I wasn't paying attention to the directions. Okay, same thing here. When I plug in 0 for x, just like I showed you right here, then the y-intercept is -4. Maximums and minimums, okay? A maximum or minimum is a y value only, but it's found at the vertex. So since this has a -a value, I know it opens down. So I know I'm going to be dealing with a maximum value. Well, how do I find the maximum value? Well, first I use the opposite of b over 2 times a and find that to be -1. That's h. Then I plug it into the equation for x and solve it, and I find the y value, and that is the maximum y value. There is no maximum x value. And if you write down a coordinate here, you're going to lose some credit because you're not telling me exactly what the max is. So here's your question 6. Your minimum, once you did the opposite of b over 2a and plugged it in, you found the minimum since it opened up. The minimum was -4. Remember, it's all about the k value. On the other side, on the vertex form side, when you start out in vertex form, it's pretty easy to find the vertex. And x equals 6, right? That's the h value. So that's actually pretty straightforward. And it's always opposite of what you see inside and exactly what you see outside for your vertex. So x would be -6. And on question 3 here, then when the real finding the y-intercept, you notice all this stuff is extra stuff. That's not really what the question was asking. All I needed to do is plug in a 0. When I plug in a 0 and go through the order of operations, there's -1, square it, that's +1. And then +1 times -3 is -3. So I really have -3 plus 3, and that's what ends up giving me the 0 for the y-intercept. And I did the same thing on the next one. For some reason I wasn't paying attention to the details of the question, and then I realized it, and I changed, and I did the exact thing I needed to. So I plugged in 0 for x and started solving for y. I got a -2 there. I square it, I get 4. 4 times 4 is 16. Now finding the maximums and the minimums when they're in vertex form, boy, that should be a piece of cake, right? Because the k value is sticking out like a sore thumb on the outside here. In this one it's a minimum because I know it opens up, and this one it's a maximum because I know it opens down based on the a values, right? -a means it opens down. So those are the answers for the first page. On the next page, question 7, rewrite the equation to vertex form. Well, you need the value of a, but you know they gave that to me. The only other thing I need is the vertex, right? And we've learned that you do the opposite of b over 2a to find that value, and you can plug it back in to find the y value that goes with it. Make sure you just follow the order of operations. And so once you found out that it was -1/2 and 1 1/4, whether you write it as a fraction with fractions or decimals, it doesn't matter. Make sure you put your -1 in there for your a, and you can leave it as that. Here the a value was 5, and you found h and k, opposite of b over 2a, plug it back in to find the value of k, and then you can use those values in your equation for a, h, and k. as you can see on my question 9, here's my real graph right here. It has a vertex at 2, -3. And then so everything is based on that axis of symmetry of x equals 2, and picking x values on either side, like 3 and 4 and 1 and 0. For some strange reason I graphed it incorrectly the first time, so that's, you can see my mess over here that I scribbled out, and I had to change some of my values in my table because I was all messed up. So vertex is in the middle, and you've got a couple points on either side. And all you have to do is plug in those values to find x's and y's. Graphing question 10, I did the same thing. I found my vertex, 2, plugged, 2 is the h value, plug it in to find the k value that goes with it. I got 4. So I was able to make my table and pick a couple x values on the left and a couple x values on the right and throw them into the equation. And when I did that, I ended up with this particular looking graph. Axis of symmetry, x equals 2. On the other side of that page, question 7, rewriting the equation to standard form, we have to follow the order of operations. So we've got to FOIL this part, raise it to the second power, right? That's whether you use the box or whether you draw all the lines and first, outsides, insides, last, it doesn't matter to me. But you got to take x plus 1 times x plus 1. That's what squaring something means, is to multiply it times itself. That's what we get inside here. Then we have to distribute the 8. Then we have to add the constant terms on the end right there that are the like terms. And question 8, very similar to that. Squaring it, right, by FOILing, then multiply by 4, then add the 1 at the very end. 9, graphing when you're in vertex form should be easier, right? Because you should be able to say 1, 2 is my vertex. You should be able, I don't have to figure anything out and do opposite b over 2a because the vertex is right in front of me. So I need to use it. And then I can pick some values on either side to plug into the equation to graph it. And there's what it looks like. Axis of symmetry, x equals 1. Question 10, also pretty easy to find 2, 4 as the middle value, and pick a couple of values on either side, plug them into the table. I actually picked these two to plug in, found those values to be -8 and 1, and obviously that one copies down here and this one copies down to there. Okay, and then you can graph your points with axis of symmetry x equals 2. Okay, so that's up to question 10. Question 11 on the next page, you have a graph. It says hint a is equal to 1. So I know the value of a. I can see the vertex is at 1, 1. So I'm going to start with vertex form. I got a 1 for a and 1, 1 for the h and k. And then you're going to go through the process of changing to standard form. So I'm going to FOIL x minus 1 times x minus 1, and that's what gives me the x squared minus 2x plus 1, but don't forget in this equation that I had a plus 1 on the very end right over there, and so that's what creates the plus 2 that you see down there. In question 12, it says a does not equal 1, so my first thought was, well, does a equal -1? It ends up not being -1, so that's not true, but that was my first thought, was it equal to -1? I could clearly see from the picture that it is negative. It's not opening up, it's opening down. It's got a -2, 3 for a vertex, and it looks like -1, 1 for a coordinate that's on the parabola. So I went through the process. I started out with my -2, 3 for my vertex, and I used my coordinate -1, 1 that was also on the graph in order to help me find the value of a. Now all of this stuff right in here, if you add those together, you get a 1, and you square it, you also get a 1. So I have 1a plus 3 equals 4. And so I can subtract the 3 and get -2. So a was -2. And then I can use that in my equation over here. So here's my vertex form. Obviously, the question says write it in standard form, right? Standard form means I have to FOIL it all out and that stuff. So Foiling it, I end up with x squared, 4x, and 4. Multiply everything by -2. Add the like terms at the end, and we get the final answer right there. Question 11. This was a problem to me. When I saw this, I was like, what in the world? Why in the world do we have an a value of -1, but this thing opens up? That's not right. So I knew right away something was not quite right with this problem, and there's a problem. So come down here and use the vertex, which is 2, 0, and one of the other points that's on the graph, 1, 1. 1 for x, 1 for y. 1 minus 2 is -1, squared is +1. Of course, that 0 on the outside isn't going to affect anything, so now I know that the a value is 1, and one of these is my vertex form. They only wanted vertex form, so I could take either one of those right there. Since my k value on the outside is a 0, I don't even need to write it. If you do write it, it's not going to hurt anything if you do. Question 12. So I know the vertex is 3, 2, and I can see another point on the graph of 2, 4. So I start with my equation with 3 for h and 2 for k. Plug in 2 and 4 for x and y. From the other coordinate, I end up with 1a right there. Be careful when you're doing this stuff. I keep highlighting that stuff because I want you to realize that stuff's together, and that's how I write that. Plus 2 over here, and I subtract the 2 to the other side to find out that a is 2, and I can write my final equation. One other type of question that will be on your quiz, given 3 points, can you find the model that goes between them? We did practice problems like that in class, so look back at your notes. But given 3 points, let's see here, given 3 points, find the model that contains them. That kind of question will also be on there. And that's where you're going to end up finding A, B, and C. That's how when we wrote our 3 equations, and then we did elimination to find A, B, and C. So that kind of question will be on there also. So be prepared for that.